In this video, we're looking at a projectile motion problem where we have a projectile launched from the top of a cliff. It's launched across this gorge and impacts the vertical face of a cliff on the opposite side of some body of water. We're given the launch angle, we're given the launch speed, the horizontal distance covered by the projectile. And what we're after here is first the flight time for the projectile, and second, how far did it fall during the flight. And the starting point for any of these problems is to just decompose that initial velocity vector into its x and y components. So the x component of that initial velocity is going to be v naught times the cosine of the angle. That's 30 cosine 29. And when I run the numbers on this, I get 26.24 meters per second. The y component is v naught sine of the angle. That's 30 sine 29. And when I run the numbers on this, I get 14.54 meters per second. So now we can get into the questions. I want the flight time for the projectile. And what I know here is the final x coordinate. I'm going to call the initial x coordinate 0. And in that coordinate system, the final x value is 90 meters. Because we have extra information in the x direction, the way to make progress on this problem is to look at the x equation of motion for the projectile. Now, because we're ignoring any drag forces here, and the only force is the force of gravity pointing straight down, the x acceleration is 0. So the standard equation of motion, which would ordinarily have an acceleration term, 1/2 at squared, simplifies because the x acceleration is 0. And I get x equals x naught plus v naught t. We set our origin, so the initial x value was 0. My final value of x is going to be 90 meters. And I have the initial x velocity, so t is the only unknown here. So t is going to be x over v naught x. That's 90 over 26.24. And rounding off to 3 sig figs, we have 3.43 seconds. In part B, we're asked for the total vertical drop of the projectile during this flight. So we write down the equation of motion for the y coordinate of the projectile. And there it is in general. And what we're going to do is plug in the vertical acceleration for an object in free fall, and that's negative g, where g is the acceleration of gravity. And just a reminder here, g is a magnitude of the acceleration of gravity. The minus sign is what takes care of the direction there, and we move that out in front of that term. Now I'm going to go ahead and say that the origin for my y coordinate is the point of the launch for this projectile. In other words, y naught is equal to 0. This is going to give us a final y coordinate that's negative, but the magnitude of that tells us the drop distance that we're looking for. So we have the flight time, that's t, and we have g, of course, and we have the initial y velocity. So it looks like we're ready to just plug things in. My final y coordinate is given by the initial y velocity times the flight time minus 1/2 times g, and we'll just use 9.8 for that, times the flight time squared. And when we run the numbers on this, we get negative 7.78 meters. And that's a fine answer to the question. It just seems to me that really the best answer is the magnitude of that. And I could tell you that the drop was a 7.78 meter drop. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.